Alright, so in our previous video in this playlist, we looked at these 6 functions. Alright, and by the way, the link to this playlist is in the description below. Alright, now here we have some of these functions that are homogeneous and others that are not. Now, if you're asked to show or prove that this function is homogeneous, or to find out whether this function is homogeneous or not, right, you will go through the steps. Multiply by your lambda or your t, right, whichever one you're using, or whichever one you're told to use, if you're told to use that. Now, whether t or lambda or any other letter, alright? Lambda and t are popular letters. But one quick way to determine whether it's homogeneous, if it's a function in x and y, or any other variable, just add up the powers of the variables. For example, this one that's not homogeneous, one power is 2 and the other power is 1. This is not. Once you see a number there by itself, it's not going to be. Alright? Here, this is homogeneous, degree 3. Why? X is the power of 3. If you add up 2 and 1, remember, y is raised to the power of 1. If you add up the power of x and y, 2 and 1 is 3, and this one is 3. So this is homogeneous with degree 3. Right? The powers of the variables are uniform throughout and has degree 3. This one is power 2. You add the powers of x and y, you get 2. But this one has a power of 3 and this one has a power of 1. It's not homogeneous. Right? The powers, when you add up all the powers, they're not uniform throughout. Here, x to the 4th, x squared plus y squared. If you add up the powers, you get 4. And this one has 4, so it is with degree 4. The 4th, the power is 4. 3 and 3 is 6, not 4. So it's a different power, and here is 2. So it's not. Alright? So that's just one quick way to check what the powers are. Alright? Now remember that, you see, x cubed, is x by x by x. This is x by x by y, this part, and this is y by y by y. So it's like you're saying, how many variables do I need to multiply to get the power? How many variables do I need to multiply in each part that is separated by plus and minus? Here is 3 of them. This is 3, this is 3. So it has degree 3. Homogeneous with degree 3. Alright? That means the same powers apply to each part. The same number of terms multiplied in each part throughout the function. Alright? Now you see, this one, you have 4 x's. That's 4 letters here added. These are 4 letters added. 2 x's and 2 y's. And this is 4 letters added. 4 y's. So it's 4 letters, 4 variables, 4 variables, 4 variables. Alright. This here is not. You have 4 variables. This is 6 and this is 2. Right? So that is one way you can determine whether the or not the function is homogeneous.